If two triangles are congruent to each other, then the 6 pairs of corresponding parts are also congruent. If we need to prove two triangles congruent, we need to look at the converse of this statement. The converse of this statement starts with these 6 corresponding parts being congruent and concluding that our triangles are congruent. Well, it turns out that we don't need all 6 parts to prove triangles congruent. We only need 3 pairs of corresponding congruent parts, as long as they're in the correct order. Our first example, side, side, side congruence postulate. The side, side, side postulate says if we can prove that we have 3 pairs of corresponding congruent parts between the triangles, then our triangles will be congruent. In this example, if AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. Then we don't need to know anything about the angles to conclude that our triangles are congruent. Our second way to prove triangles congruent, side, angle, side. Again, we don't need all 6 corresponding parts congruent. We just need 3 as long as they're in the correct order. If AB is congruent to DE, BC is congruent to EF, we have side, side, and we need the angle between those sides to be congruent. The angle between the congruent sides is called the included angle. The included angle between side AB and side BC is angle B, and the included side between DE and EF is E. So we need 2 pairs of corresponding congruent sides and the included angle to be congruent. Then we can conclude that our triangles are congruent to each other. Let's look at some examples. If we look at example 1, we have 2 triangles in the picture. Here's one triangle, and here's a second triangle. Well, given to us, we have 1 pair of congruent sides and a second pair of congruent sides. Since we only have 2 pairs of corresponding congruent parts, we need 1 more pair of congruent parts. Well, in this case, both triangles share this side. Since both triangles share this side has to be congruent to itself. So we have a 3rd pair of congruent parts. So how are these triangles congruent to each other? Side, side, side. I can abbreviate side, side, side with SSS. Our second example is the same picture with different givens. We still have our 2 triangles. And we have 1 pair of congruent sides and 1 pair of congruent angles, and then a shared side. That shared side will be congruent to itself, So in this example, we have two pair of congruent sides and the included angle between those sides. We have side, angle, side. The reason we know it's side, angle, side is this angle is between my pairs of congruent sides. And in the last example, we have two triangles. And between those two triangles, we're given a pair of congruent sides and a second pair of congruent sides. We need to have one more pair of congruent parts in order to prove these triangles congruent. And unlike these first two where we had a shared side between the two triangles, these two triangles don't share a side. But by the way that the triangles are drawn, we do know we have another piece of information. This angle right here is vertical to this angle. So these two angles are vertical, which means that they have to be congruent. So there's our third piece of information. And it just so happens that this angle is between my pairs of corresponding congruent sides. So these two triangles are congruent by side, angle, side. Let's look at a proof to prove triangles congruent. We're given that WZ is parallel to XY and WZ is congruent to XY. And we need to prove that triangle WZY is congruent to YXW. Let's first figure out what method we're going to use for our proof. We're given that these two sides are congruent. So that's one piece of information. And by the way that these two triangles are drawn, they share a side, and that shared side is WY. So WY is going to be congruent to itself. So we have a pair of congruent sides and a second pair of congruent sides. We need one more piece of information. Well, we don't know that XW is congruent to YZ. It looks like they're going to be, but we can't just say that they are for our proof. Instead, we need to go to our first given. We're told that WZ is parallel to XY. Last chapter, when we had parallel lines, we knew about angles. If we look at this picture, XY is really a line, and WZ is really a line, and our transversal is WY. So when we have a line and another line parallel to that line, cut by a transversal, we know about angles. Well, in this case, we want angles that are also parts of the triangle. If we look, this angle and this angle are not on the same transversal, so they're nothing of each other compared to these two parallel lines. And if we look at this angle and this angle, these two angles are alternate interior angles, but they're alternate interior angles between XW and YZ. Instead, we need to look at these two angles. These two angles are alternate interior angles between XY and WZ, which means that they have to be congruent to each other. That gives me my third pair of congruent parts. So in order to prove these two triangles congruent, I want to use side, angle, side. Now side, angle, side is going to give me my roadmap to write my proof. I'm going to start with this first pair of congruent sides. That first pair of congruent sides was WZ and XY. We know that WZ is congruent to XY because that's given to us. And since I have a side congruent to a side, that gives me a pair of congruent sides. Now I want to go to the congruent angles. Well, in order to get the angles congruent, I need my lines to be parallel. And I know that my lines are parallel because that piece of information is given to me. So parallel lines tell me about angles. Which angles? This one and this one. So I need to name these angles correctly. To name this angle correctly, I need to use 3 letters. If I just said angle W, I wouldn't be exact enough. So I'm going to call this angle angle ZWY. And I'm going to call this angle XYW. I have to use 3 letters for both of these angles because around this vertex there's 2 angles. Why are these 2 angles congruent? Well, they're alternate interior angles between 2 parallel lines. And by the alternate interior angles theorem, those 2 angles will be congruent to each other. I have a pair of congruent angles. I can put a little a off to the side. So I have side, angle. Now I need my third piece of congruent parts. In this case, the third piece is this shared side. Well, this shared side is WY. And since WY is on both triangles, I can say that WY is congruent to WY. What property allows me to say that WY is congruent to WY? Well, that's the reflexive property. A line segment is congruent to itself. It's this shared side between both triangles. That's enough to prove that my triangles are congruent to each other. WZY is congruent to YXW. Notice that the order keeps my corresponding parts congruent to each other. And the reason that these triangles are congruent to each other? Side, angle, side.